Now the next experiment will be the estimation of the friction factor. Exactly what happens is, here we have a pipeline. It can be made up of steel, it can be made up of cast iron, it can be made up of PVC, anything else. So when the fluid is moving from one point to another point, as you know, this pipeline will be offering some resistance to the fluid flow. So that is our estimation in this experiment, and it is denoted by F, and then we are going to find the variation of F with respect to NRE, where the graphs are plotted and log. This is our main experiment, and this is the use for it. Mainly it is used for estimating the friction factor. So here you have a sump tank. The sump tank, the water should be there first point, and the pump is there. From the sump the water will come to the pump. If you on the pump, the water will come like this, and now you are going to open the valve. Initially this valve will be closed, and then you are supposed to check the water level inside this, and then slightly open this valve V1 and then start the pump. So water will come from here and then it passes through it. Now once it attains steady state, then you open the valve V3 and V4, so that you are aligning this pipeline to the YouTube manometer to measure the pressure drop. So for a given value of V1 opening, the water will be falling into this, and then you know initial height and then final height and time of collection. With this data you can calculate the volumetric flow rate. And here you have YouTube manometer. With the help of YouTube manometer, you know the RM value, and from there you can measure the delta P value. So these are the readings which you are going to take it. You are going to have what? Initial height, final height, time of collection, and then RM value here. So when this tank is full, what will happen? You will open the valve V2 and then you drain it out. So next step, you again open this valve slightly, increase the valve, increase the flow, and then wait for 1 minute to attain steady state. Then again you can calculate the RM value and then start, stop, and then time of collection. Like that you take a set of readings, and that brings the end of the observation or the performance of this experiment. Then after this we will have a tabular column, where in the tabular column, as said, initial height, initial level of the water in the collection tank meters I have written directly, final level of the water in the collection tank meters directly, time of collection in seconds for calculating the volumetric flow rate. So with these three data I already shown in the videos, you can calculate the volumetric flow rate Q, provided you should be given the cross sectional area of the collection tank, that I will give you in the given data. Then you know manometric reading, RM value, convert to meters, and then find delta P. And then now the velocity. How to calculate the velocity? Yes, you know the volumetric flow rate passing through this pipeline, and the diameter will give you. So diameter you will convert it to pi by 4 d square. So you will have the volumetric flow rate meter cube per second divided by cross section area, you get the velocity. So like this you will find this column also. Then from this you have Reynolds number, that is rho V bar d by mu. Again I explained you in the videos. You calculate this one also. Then you will have the friction factor. Now here in this I made a slight modification because it is a tedious experiment, I know. So hence I am reducing it to a small value, okay, smaller procedure. So instead of using so many values, I will be giving you fanning equation only, which we have studied in our equation, in our this thing, where the F is given by, friction factor is given by, for a wide variety F will be given by the value delta P GC D divided by 2L rho V bar whole square. This formula already we have seen in our theory part. So this we will apply now here in this to estimate the values of friction factors. So what is delta P? Yeah, you know here all these values, very good. GC you know, D diameter already gave you. Length is what? That is the distance between the two pressure pots. This also I will give you in the examination, don't worry. The distance between this point to this point is called as the length of the pipeline, okay, in which I am going to measure the value of friction. If I make a change, if I try to change this, then of course L value will change. L value is nothing but the distance between these two pressure pots, okay. So this is L. And what is rho? Density of water. V bar whole square, of course you are going to calculate here in the velocity, that you are going to put it here, and then you will find the friction factor. And lastly what you will do? Convert these values to LOG, convert an NRE value to LOG, and these two values only you are going to plot it. Okay. So, and then in the result you will say the variation of log of f with respect to Reynolds LOG NRE is plotted in the graph. Okay. Thank you.